You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show. Hey all, we had a great time at KubeCon this year in Salt Lake City. We met so many people, and so we thought it might be good to just conclude the show with talking to a few people about their takeaways. And so what we're going to see here are 3 interviews we did at the end of the show. It gives a glimpse of where we are right now in the Kubernetes world. We'll hear about a lot of discussion about Argo, WebAssembly, and the challenges of migrating and what actually can be done, when you're thinking about using tools such as Carpenter, a new open source project. So hope you enjoy it. All right, it's in the last hours at KubeCon. It's a Friday afternoon, and I'm here with Shivay, Lamba. How are you?
I'm doing really well, Alex. So good to be here. It has been a wonderful KubeCon, and I think the major focus of this year has been a lot of WebAssembly, a lot of AI.
Right. I would love to get into that a little bit, but let me just back up a little bit because I would love to hear your perspectives, and I would like to focus particularly on WebAssembly. What were some of the developments you saw here at the show about WebAssembly?
Yeah, so I happen to work at Couchbase. It's a NoSQL database company, and we have been collaborating very closely with Wasm Cloud, which is an open source WebAssembly project that provides platform as service, and you can very easily deploy WebAssembly modules through the component model with the help of Wasm Cloud. So we worked very closely with the folks at Cosmonic and Wasm Cloud to implement a solution for American Express. And American Express had one of the best sessions at this WasmCon, where they showed that how they built a complete internal developer platform powered by Wasm Cloud and WebAssembly. So what we're seeing now as a theme is that a lot of companies are now actually implementing WebAssembly as part of their developer tooling. And the biggest consensus is that the toolings that are being developed are primarily showcase WebAssembly as a platform so that customers or the end users don't even know that WebAssembly is being used. But all of these developer platforms are being powered by WebAssembly. So that's one of the biggest themes, that more companies are now implementing WebAssembly rather than just exploring what WebAssembly is. And that's what most of the talks around the cloud-native WebAssembly ecosystem were about. That now we are looking at observability. We're looking at how you can actually minimize the deployment costs when it comes to working with WebAssembly.
What kind of questions are you hearing from people about WebAssembly, and how are those different from a year ago?
Yes. So probably if you go even 1 year ago to WasmCon 2023, a lot of companies were still figuring out, okay, is WebAssembly a good use case for their company? If it is, how do you get started? How do you implement WebAssembly as a platform? Right? So those are the kind of questions that were most commonly asked. There are, of course, still a lot of folks who are asking these questions, that how do we implement WebAssembly in today's landscape? But a lot of the questions have now transitioned into that companies are now actively investing time and efforts, engineering efforts, into implementing WebAssembly. And they are leveraging platforms like Fermyon, SpinCube, in order to test out how you can use WebAssembly inside of the Kubernetes ecosystem. Or, of course, the larger picture is that as we see that there is a general rise in platform engineering, a lot of companies are moving away from standard microservices and actually going into platform engineering as a concept, right? Because the biggest takeaway from platform engineering is that you're having a standalone platform where a lot of companies might have major tech stacks and they're working in silos. So they're trying to bring all of their technical teams together and have one standard platform through which they're able to interop. And that's where WebAssembly really is a standout performer, because you can take languages, code written in whatever language. It could be Python, .NET, C# or JavaScript, and you can compile it all together into a WebAssembly bytecode and then execute it. So the question now is that, okay, companies are all actively using projects like Wasm Cloud and SpinCube, and now they are evaluating they have built POCs around it. Now how they can deploy it, how they can productionize and ensure that they can add those similar type of deployment tools like for monitoring or open telemetry, and how we can add those to WebAssembly applications so that you can monitor the costs and the network requests.
So where do you see WebAssembly going, based upon the conversations you're hearing, what kind of questions speak to the direction of WebAssembly?
Yeah, so I think one of the most recent advancements has been open telemetry connectors. So today, SpinCube, Wasm Cloud, Wasm Edge, all these projects are actively working on getting better at being able to generate logs, metrics. So if we talk about just OTel and the most basic melt framework, which is metrics, traces, and logs that you need to generate for applications in production. So most applications that are now being developed with Wasm are asking questions that how can we effectively get these logs so that we can monitor the applications in production. A lot of companies like American Express and Nokia and then Apple, the companies that are working in this ecosystem, are pretty much now having conversations with Cosmonic folks or Wasm Cloud who they are integrating to see how they can make it more effective in production.
Are people getting confused about this story about containers and Wasm replacing containers?
I think there's still, of course, discussions around whether we should choose containers versus Wasm. And the discussion that was probably 2 years back is still pretty much relevant even today. The fact being that Wasm is not a replacement for containers.
Right.
Because we are still relatively new into this ecosystem of being able to do things like networking.
But is that still confusing people?
That is, yes, that is. But we are also seeing more and more WASI proposals that make WebAssembly more effective for networking. So, for example, we have the WASI HTTP proposal, which is now being officially adopted in a few months' time at NGINX. So, yes, there are certain areas where we are still seeing some level of effort that still needs to be done. For example, with the WASI Observe proposal, which is a very new WebAssembly proposal for observability, which will allow guest functions within a WASM module or a component module to be able to generate logs and metrics that are happening within the WebAssembly component model. So they are still brand new. So there are still questions around how you do networking effectively.
Right.
The HTTP requests over networks. How do you do it more effectively over WebAssembly? So that's still being standardized, and I think that's where you would still probably use still use containers. So I guess even today the main use case is that there are areas where you'll still use containers, probably for more long-standing tasks. But there are these short bursts of use cases. It could be ML inference. It could be some other task that you only want to execute in a very short burst of time. And that's where WebAssembly still is a standout performer. Where you might want to run thousands and 10,000s of different requests, where your WebAssembly module starts up, you run the execution of whatever function you want to do, and it then closes. And you can do this very quickly and not have to worry about the cold start time of the containers.
In conclusion, what are you looking forward to for KubeCon London in 2025?
Yeah, I think there are two main things that I'm really looking forward, specifically with respect to WebAssembly. The first one is the Web GPU WASM integration. So there is a WASI proposal for adding support for Web GPU. And there are companies today, in fact, there are a couple of talks at WASMCon this year around how we are using Web GPU with WebAssembly. And that's one of the biggest use cases for being able to make more production-ready AI applications, or if you're doing a lot of 3D visualizations, that's where you can leverage the Web GPU APIs. And one of the direct integrations over here is that if you're running WASM workloads in Kubernetes, and once we have good enough support for the Web GPU APIs, you could very easily plug in GPU support for WebAssembly and run it as part of your containerized workloads. Because I think that's still one of the areas which is still relatively new, and companies haven't really executed it that much. So as we see that more and more companies use GPU-based workloads on Kubernetes, there will be a support for WASI to be able to directly use GPUs, right? So if there are more compute-intensive workloads, you can leverage the combination of WASM and the Web GPU. And I think that will be one of the bigger conversations that we'll be having at KubeCon London. And as I mentioned, that as platform engineering grows, the support for WASM and generating, the WIT gen, or having WIT definitions for more and more integrations with WebAssembly, that will be the main focus going forward in the next year.
Well, Shivay, thank you so much for your time today. I've enjoyed talking with you, and thanks for coming by.
Absolutely. Thank you so much, Alex. It was lovely meeting you.
Okay, it's Friday afternoon at KubeCon in Salt Lake City, and I'm joined for a conversation with Josh Cypher of Sonos.
Hello.
How are you?
I'm doing great. It's been an awesome conference.
I'm glad to hear it. I understand you're out of Nashville.
Yeah, Nashville, Tennessee. I work remote for Sonos. We're headquartered in Santa Barbara and Boston, but I get to kind of be right in between, which is nice.
So why do you come to an event like this, and what did you hear that was new to you, and what are you going to go back really thinking about?
Yeah, so I actually spoke at KubeCon. I participated on a panel about the state of Kubernetes compute optimization and the role of AI that plays into it. And so I was very interested in, AI has been a huge theme of KubeCon this year, and I've been very interested to see how people are adopting those patterns, and especially from like a sustainability standpoint, because like we've just been throwing so much at AI, and we're not really thinking about like the cost of that on the environment and things like that. And so one of my fellow panelists, Katie, talked about like Kepler and how it's like changing the game in terms of how we can provision compute in a sustainable way. And I found that just super, super interesting. I also really enjoyed the keynote, I think on the first day from CERN, where they were talking about how they run their multi-dimensional workloads and multi-cluster workloads all over the world. I just found that super interesting. And I'm interested to see what kind of research still continues to come out of there. It's not just particle research, it's compute research that applies to our industry too.
And so what were some of the new things you learned outside of the panel you were on, and what you heard from CERN in the keynote? Are there things you came that you wanted to learn about and that you did?
Yeah, I went to a talk on moving to Gateway API, and I off of just Ingress API, and I think that's like really interesting, and I want to learn more about it for sure. It looks like it's a pretty straightforward transition. There's like some really cool tooling out there that they've come out with to help.
Ingress.
Yeah, for Ingress. Yeah, so I think it's literally called like Ingress to Gateway. You just run a command. It crawls through your cluster, prints out the objects, and then you just go ahead and pipe them right back in, and boom, you can move to Gateway API.
And I expect that Sonos uses Kubernetes?
Yeah, we're pretty heavily involved with Kubernetes. We still have a lot of EC2 resources too that stand on their own. But yeah, we run a whole bunch of different clusters in production and for testing and building all of our binaries that we run on our soundbars.
When did you start using Kubernetes at Sonos?
I started using, Sonos started using Kubernetes about 6 years ago. It started with some self-managed clusters built on top of kops. At that point, EKS wasn't super mature. We are an AWS shop. EKS wasn't mature enough for what we needed, so we opted for the self-managed clusters. I've only been there for the past 3 years, so most of my time has been spent migrating things into EKS.
Okay, migrating into EKS. Mm-hmm. How's that migration gone?
It's gone really well. EKS has come a long way. It's very simple. We also recently adopted Carpenter for compute provisioning, and that's made things so much easier.
Maybe you could just briefly explain what Carpenter is for people who may not be familiar.
Yeah, for sure. So Carpenter is a compute provisioner that uses real-time resource usage to make scaling decisions. And I think it's going to really change the game on how we provision compute, because we're not stuck in these rigid configurations that vertically scale huge swaths of instances. It's like instead you can bring in exactly what you need when you need it. And then when you're done with it, it'll start to bin pack, it'll consolidate nodes, and you end up with a lot better efficiency, a lot better utilization, no more over provisioning. It's a really cool tool.
And so you've been using that?
Yeah, we've been using Carpenter pretty heavily now for about a year, maybe a little bit less. And it's resulted in a whole lot of cost savings for us. It's actually probably the best success story. We're able to, since it can bring in nodes a lot faster, we're able to leverage Spot for our less stateful workloads.
Spot instances?
Yeah. And so Spot's been a huge thing for us to adopt to. I mean, it's like a 40 to 60% cost savings, probably in practice. I think Amazon claims like up to 90%, but we're seeing about 40 to 60. We still spread our topology, so some things still always run on demand. It's been really interesting being able to leverage Spot and having that direct integration into the Spot market.
The migration to EKS.
Mm-hmm.
How many years are you into it now?
We're probably about 2 years in.
Yeah.
We have a self-service infrastructure platform, which most people, I feel like, that's what I hear nowadays. And so there's a shared responsibility between our development teams and our infrastructure team to do it. And so we started out kind of hand-holding things and doing that white glove delivery with some pretty critical services. But it is a slow trickle trying to get our developers to move everything on board. But we're getting there. Like I'd say we're probably about 75% moved over. We're just now starting to decommission those COPS clusters. And it's going really well.
Great. So what's next in your deployments, do you think, for Kubernetes?
So something that we're experimenting with right now is actually training AI models to look at the seasonality of our workloads and use that for predictive autoscaling. Carpenter has a lot of hooks into it where we could do something like create a custom admission controller and hand that over to the Carpenter API and let it start scheduling pods and nodes based on historical patterns, which is really cool. And so that's kind of the next forefront. It's more research, and I'm not going to just put it into production. Probably start with like build and test, but I think it's going to be really cool to dig into. And then I'm hoping we can share some of that with the community now that Carpenter's open sourced and been handed off to the CNCF.
What have you learned at this show about about AI and Kubernetes that you'll bring back to Sonos?
So I've learned that there's a lot of common interest out there in the field, and that everyone's really ripe to collaborate on this. Like, we all have similar concerns about saving cost, about being sustainable, and there's going to be a lot of opportunity for us to reach across the aisle and collaborate with other organizations that are doing this, not necessarily just commercial options, but in the open source world. And so I'm very excited to look into some of these projects that I've seen, like Kepler, of course, Carpenter as a whole, and how AI starts to really play a role in how they grow.
Great. Josh, thank you so much for taking some time to talk. Yeah, it's been interesting. It's the last day at KubeCon, and we're getting some perspectives on what people are seeing here at the show, what you saw at the show. And I'm here with Paul Stovell, and he's the CEO at Octopus Deploy. I went on your trip down the Seine in Paris when you all at KubeCon Europe. Did that at KubeCon Europe, and I talked to a lot of interesting people on that ride, and in comparison to then, I heard a lot of people talk about platform engineering. Are you still hearing about that topic here, or are there other topics that are more of interest?
Yeah, I think there's two big themes that we've been hearing at previous KubeCons and even more at this one. I think platforms are a big part of it, and I think the other part is Argo specifically is a really successful, huge project here, and the sort of GitOps movement that Argo, I think, represents and drives. So our focus here has actually been very much on the Argo space and what's going on there. And then, still a lot of interest in platform engineering. I think there's a period where I think last year there was a lot of excitement around the idea of building platforms. Now there's a bit more reality around building platforms, so we're seeing a bit more of that.
Are people, and what are they asking particularly about GitOps and deployments? A lot of the work is still very manual. Like, you might be able to update, one developer environment, but if you're dealing with tens of multiple environments, the scripting issues become greater for the infrastructure as code. The YAML scripts need to be updated. And so, it becomes quite cumbersome, and it still seems to be a big problem. What are people saying about that here?
The way I think most people think about GitOps as like a way to do automation, but it's not really. I don't think that's the most helpful way to think about it. I think the way to think about it is more of an evolution in how operation teams work with infrastructure. So if you go back to the days where we used to use SSH to manage servers, right? We've got a live living thing that has state, and we're manipulating that state through a terminal directly on the machine. And no one else on the team can see what we're doing, right? Unless they're watching over our shoulders. There's no way to kind of make sure that you do all those same things in the right order every time. And if something happens to that machine and you lose it, it's hard to sort of get back to that world. I think there's been an increasing evolution over the last 20 years or so to try and bring some engineering discipline to that. So we moved from infrastructure being kind of something that operations people do to something that we try to engineer. And so you've got Puppet, Chef, Ansible, those kind of tools where there's still a stateful infrastructure, a stateful computer that's running, but it's being managed in a way that has some engineering discipline through, Ansible runbooks that are stored in Git. But GitOps goes even further, right? Because Kubernetes talks YAML natively. We can store those files in Git and we can use that to manipulate it. So it's a great way of it is a giant leap forward in how we do infrastructure, but it doesn't actually really change the automation question, right? You sort of still get back to, okay, if I'm going to roll out a change across a lot of clusters for a lot of applications, that's a lot of changes to Git that need to be coordinated in a specific order. And so everybody is grappling with that problem a little bit differently and the challenges around that. And, there's one of the big advantages is in a world of GitHub, everything is a pull request. So that's really cool. There is no approval process when I'm doing stuff in SSH on a computer, but there is a pull request when I'm making a change to a file in Git. So that's a really great level of engineering discipline applied to GitOps. But approving 400 pull requests because I'm doing stuff at scale, that's probably not so fun. So that's another challenge.
Does that translate to people in terms of how they think about cluster management overall?
Yeah, I think so, because particularly the tooling is really sort of fairly focused on a specific cluster or maybe a handful of clusters that are close together. There's always a layer of abstraction that's needed, and even when you think about a question like, I'm using Kubernetes as my enterprise computing platform for everything in my company, and I know that there's a security vulnerability in some version of MongoDB. How many MongoDBs do I have? How many of them do I update? In a GitOps world, how many pull requests do I have to get approved in order to change that? This is something that the tooling still isn't really solving today.
It reminds me of conversations I've had with people about reproducibility, for instance, and and how can you almost virtually create clusters so you can have the components archived and then be able to just pull them all together really quickly.
Yep.
Is that a trend that you're seeing at all?
Yeah, I think that's still really big, and particularly for if for internally developed applications, think about a testing process where we're trying to, we know there's a bug that came into the product, but we don't know when it came in.
Right.
We think it was sometime in the last 6 months or a security thing. Right. We're trying to pin down what customers might have been affected. Mm-hmm. So then we have to sort of bisect where was the change made. Let's roll back to an old version of everything running, see if it still exhibits the same behavior, split the difference, So the more reproducible. And this is the amazing thing about GitOps. Go back to that world of SSH terminals, on Linux instances. There's no reproducibility in that. With GitOps, we definitely get a lot closer to it.
What were people asking you when they were coming by the booth? What were some of the questions you were getting from them?
I think there's a lot of interest in Argo, and we acquired CodeFresh at the start of the year, and so CodeFresh have been probably one of, if not the most prolific vendors supporting Argo, obviously behind Intuit. But as far as vendors commercializing things in the Argo space, which is important because it helps people adopt Argo more broadly, there's a lot of interest in that. But the challenges are all kind of the same. Argo, it does kind of two main things for most infrastructure teams. So infrastructure teams start out using Kubernetes, right? They set up Kubernetes, they set up some applications in it, they start creating YAML files or copying and pasting them from the internet. And then the very next step is it feels really logical to store that YAML file in Git. And so Argo is doing a bunch of automation around, you change the Git file and we automatically synchronize that change into Kubernetes. But that's probably actually not the thing that makes Argo popular. I think the thing that makes Argo really popular is if you're an application engineer that hasn't kind of spent the last 6 months learning all the details about Kubernetes, there's a lot of words and concepts that are very Kubernetes unique that probably don't even translate from the virtual machine world, where you've got an application that's running, but you don't really understand how it runs in the way that you used to have a sort of mechanical sympathy for how your application ran in a VM world because it was the same as how it ran on your laptop. And so now it's running in Kubernetes and there's all these things you don't understand, but the Argo user interface lights all of that up for you, right? So it's become, I think, the observability aspects of Argo are actually probably the thing that makes it as popular as it is. But the challenges are still the same. What do we do when we've got a lot of Argo instances? What does this look like when it's not just 5 or 10 people doing GitOps at our company, but it's 100, it's 1,000? What do we do when we want to make sure that changes that we make in production around how our application runs don't get forgotten to be applied to our dev and test environments, and then a bug gets introduced because the networking configuration is different. And so that whole promotions process of how changes move in a GitOps world, there's a lot of interest in that sort of thing.
a lot of interest in the Argo discussion on how you think about GitOps, how you think about version control when you're scaling it out to a lot of people in the organization.
Yeah, if you meet any customer that uses Argo at any serious scale, and you ask them like how they're using it, they'll say like, we're using Argo and it's great, they love it. But then you sort of say like, okay, how are you solving these kind of problems, these kind of problems? And what you find is, there's Argo on one side, there's Jenkins or GitLab or something on the other side, and there's a whole lot of custom scripting, tooling, things that the organization has built that kind of bridges those two worlds, right? Because if we're changing the version of Postgres that's running in all of our Kubernetes clusters all around the world, we don't want to go and do 500 Git commits to make that happen. Right. So, the way you replicate changes like that out, like that's a thing everybody's kind of solving in a unique way.
That's the issue, isn't it? It's replication, isn't it?
Yeah.
That seems to be a challenge that we'll hear more about, don't you think?
That's right. Yeah.
And how you think about...
And also like security. So think particularly like one of the themes we saw in the keynote was around Argo. I think got a lot of popularity, particularly for SaaS companies that were doing stuff with Kubernetes. But now you've got companies increasingly using it within enterprises. And, logically and sensibly, the engineers in an enterprise shouldn't probably have access to every single application that the enterprise is building. And so, the Argo user interface, even just to be able to go and get the logs or something from a container, that can't be as open as it tends to be in like a startup, for example. And so there's a lot of issues around security that, in particular, CodeFresh is still, now they're part of Octopus, we're growing the open source team. We do a lot of work in that space, and a lot of that is very security focused because security, permissions, auditability, all of those things are really important.
What about snapshots? Like being able to take snapshots and then archiving those snapshots so you can actually have the more secure environment?
I think that's a part of it, but you do get a certain amount of that by default with the fact that it's backed by Git. So we've got some ability to at least kind of get back. Now we'll lose some data, but to get the system running the way it used to run, there's enough files within Git. I think one of the challenges is, what does it look like again across large teams where there's more than one GitHub repository, right? There's 100 of them, and so okay, I can bring up the commit history for one repository, but what does that look like over 100 of them is still a unsolved question.
Well, Paul, thank you for taking the time to talk. It's been interesting to hear your perspective.
Yeah, very busy here.
Great.
Thanks, Alex.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.